Now let us take a look at the core architecture of RISC-V. So here we will be looking at a couple of interesting RISC-V core projects, as well as we will also go through a couple of processor design concepts, which will give you an understanding of why the core architectures vary from one to another. So here I will not be going very detailed into the processor design techniques, but I think the kind of information we will be discussing today will help you to go to your textbooks and study more details on each and every techniques. So first let us take a look into a couple of interesting core projects. Okay, the first example here is a PULP platform. So PULP is a is an abbreviation for parallel ultra low power platform. This is a platform developed by ETH Zurich. ETH Zurich is doing a lot of very interesting RISC-V core programs. So if you look at the PULP cores, there are multiple variety of PULP cores from ETH Zurich. ETH Zurich is a university based in Switzerland. And if you look at the 32-bit category of cores, they have very low-cost cores like zero RISC-V, micro RISC-V, and then comes with then there are some cores coming up with the 32-bit cores coming with some DSP enhancements like RISC-V, RI5CY. It is also called RISC-V. And they have SIMD enhancements for DSP kind of processing. And we will get to more details of this RISC-V processor. It's a very interesting RISC-V project from ETH Zurich. And this RISC-V processor has some floating point extensions, so it's called RISC-V plus FPU. So it supports variety of instruction sets as you can see in the foil. So this 32-bit cores from are really useful for a lot of control applications, IoT applications like that. And then the PULP platform from ETH Zurich also has a 64-bit variant of the RISC-V processor. This 64-bit variant is called Arien 64-bit, and it has the Linux. It is a Linux-capable core. When you say Linux capable, I mean Linux as a operating system or complex operating systems like Linux needs to have certain enhancements in the processor. So Arien has some of those enhancements. So RISCY Core, as I mentioned before, RISCY is a 32-bit core from ETH Zurich in their PULP family of processors. As you can see here, it is a four-stage pipeline. And here there are, there is an instruction fetch state you can see here, which is one stage of the pipeline, and then instruction decode stage, and you also have execution pipeline stage where you have ALUs, multipliers, then the multiplier and MAC unit. Then there are dot product units, divider units. I mean, this kind of functional units are there as part of the execution pipeline stage. And then there is a write back stage. So this is the last stage of the pipeline where you can see load storage unit, which finally writes to the memory and read from the memory. So this is as I mentioned, it's a four-stage pipeline, and it is mainly, each core design has some unique features and for the kind of applications the core is targeted for. And this particular family of RISC-V processor is targeted for energy efficient IoT applications. So the kind of implementations they have, it has 40 kilogates equivalent gates of logic, and logic has 30 logic levels. 30 logic levels represents the data path latency. And there is a core mark specification. So core mark is like the performance benchmark. So core mark is typically used between processor cores to benchmark them against other processor cores. So core mark is for ETH Zurich PULP, like RISC-V core is 3.19, which is quite good. And there are various extensions available for this particular PULP family processor. The extension X stands for DSP applications. And I'm getting to the next family from ETH Zurich, which is Arien core. As I mentioned before, Arien is part of the PULP family, but it is a 64-bit core. And this is a Linux-capable RISC-V processor. Okay, so it naturally has a lot of additional components there to support a complex operating system like Linux. As you can see, there are multiple pipeline stages, as well as a couple of memory management unit, and a couple of interesting processor design concepts are introduced in this Arien core. It is definitely not for extremely low energy, but I mean it is a medium range Linux bootable processor family. And another interesting project is UC Berkeley has Rocket cores. Okay. UC Berkeley is of course the founder of RISC-V family processors. So this is a very interesting project, and it's a very quite stable core from UC Berkeley. It's available open source. It's implemented using Chisel programming language. I mean, it's an extension of Scala. So as you can see here, it has a six-stage pipeline: PC gen stage, fetch stage, decode stage, execute stage, memory write back stage, and finally commit stage. So this is actually it has an optional FPU. So it is a single issue scalar processor. I mean, we will talk about the issue and other details in the upcoming foils. And the Rocket core consists of a fast L1 instruction cache, as well as a L1 data cache. So we'll get to more details of the architectural details later. But this is just we took a very brief look at 3 different categories of processors.